In this problem, it says a line segment is drawn from point P, which is 4, 5, to point A on the y-axis. Then a segment is drawn from A to point B that lies on the x-axis, and finally a segment is drawn from B to point Q, 11 at 11, 3. Determine the least total sum of the lengths of these three segments. All right, so here's the picture. We've got point P right here. Then we've got point A here, point B here, and then we've got point Q. And so we've got this length, and that right there. So we want to know, what is the smallest way you can do that? Well, what you kind of want to imagine is you want to imagine that we're playing billiards, and we're saying, all right, from point P we hit the wall, it bounces off at point A, then it bounces off at point B, and then it lands at Q. And the way you can do this is to imagine, all right, to imagine the shortest distance, what we have to picture is with these bounces, it's as though we're hitting in a straight line. We have to imagine that the axes are kind of like mirrors. And so how does that work? How do we treat this as though it's a straight line problem? Well, what we do is we say, all right, first we're going to reflect Q over the y-axis, or sorry, the x-axis. So it was 11, 3. Now it's 11, negative 3. So we've taken care of that reflection. Then we have to take care of this reflection. So we have to reflect this over the y-axis. So over here, it's going to be at the coordinate negative 11, negative 3. That takes care of that. And so what we're really asking for is, what is the straight line distance between negative 11, negative 3 and 4, 5? Because when you bounce off the x and y axis, the length will not change. And that's the shortest distance between 2 points, is a straight line. So the distance between any 2 points is really nothing more than just an application of the distance formula. Or sorry, of the Pythagorean theorem. So from negative 11 to 4, that is a length of 15. From negative 3 to 5, that is a length of 8. And if you've memorized your special right triangles, you'll realize that this is 17, is the length of the hypotenuse. And that right there is the answer. And we're done.